Example 7. The uniform truck ramp shown in the figure has a weight of 2000 Newton and is pinned to the body of the truck at each side and held in the position shown by the two side cables. Determine the tension in the cables. Now, so what does it mean? I believe most of us have seen already what a truck ramp is, but for illustration, this is viewed in 2 dimension. But if in 3 dimension, so let us say if this is our ramp, right? Each side is hoisted by a cable, right? So this is where our truck it lowers or up based based if on how it is configured. But given that it is viewed like this, it means there is tension in our cables. Okay. So although that this is viewed only in the 2 dimension, so our tension will be calculated, the tension that we'll be able to calculate later, we will divide that into two so that we will be able to know the tension that each cable is experiencing. Okay. So we first draw our free body diagram. Okay, now our ramp has a measure of 30 degrees, right, from the horizontal, and then this at the center, this is where our 2000 Newton weight is applied. This is 2000 Newton, and then this is A, right? This is the center of gravity G, and at B, there is B, where B is the location where our tension is applied at this ramp, which is, okay, wait, let me zoom in. This is, okay, okay, this is going down. Now, our tension is applied, cable is 30 degrees with respect to the horizontal. So therefore, this is our T, right? So this is also 20 degrees. This is at B. Okay. Now from B to G, that's 0.6 meters. So perpendicular distance going down. This as well. This is 0.6 meters. And from G to A, this is 1.5 meters. 1.5 meters. 6, 1.5. Okay. Now, so what we're going to do is very straightforward. If this is 30, this is also 30 degrees, right? Because if we try to create another horizontal here, this is 30, this is 60. So this is as well 30 degrees. So what we have is we will resolve our tension into its x and y component, right? And that is, this is T sub y, and to the right is T sub x. And of course, we will be using the 20-degree angle. Okay, now for our 2000 Newton, we have, if we base it with our, using our 30-degree angle, we have, let us call this GY, no, oh yeah, G, oh yeah, just call that Y prime, just call that Y prime. And then here G X prime, right? Okay. And then we have going up AY, going to the right, A sub X. Okay. And of course, this is our reaction set A. And now we can now know the value of our tension, right? If we do moment about A, because as we all know, angles for a 20-degree angle is given for our tension, and then the dimensions is also given, and the inclination of our ramp, which is 30 degrees, is also given. So therefore, if we want to calculate T, we do moment summation about A, because if we do what do you call this? If we do uh force summation in either X or Y, we'll end up with two unknowns. And that is the Y component at A, Y component as well for Ty and Tx and Ax. Now, so we do summation of moment about A is equal to 0, assuming counterclockwise is positive. Okay, so T sub Y causes a counterclockwise moment about A, so this is positive. Now T sub X causes a clockwise moment, so minus. Now our 2000 Newton, so I believe we just delete these color red portions here to for us to not confuse ourselves. Oh, just the color red. Red. Anyway, let me just write black on top of our red. Okay, there you go. And our 2000 Newton still causes a clockwise moment. No, sorry, a counterclockwise moment about A. So this should give us T sub Y, right, going down, and its perpendicular distance from A. We just have to follow the line of action, right? And this is let us call this as X, and this is the perpendicular distance of T sub X from A, which was called that Y. And this is X, so that's T sub Y times X. Okay, let me use parentheses. Okay, and then 2000 Newton, another color green. Okay, this would be the perpendicular distance of 2000 from A. Let us have that as M. Okay, so that is plus 2000 times M. And then minus T sub X times Y is equal to 0. Okay, now for our T sub Y, we can express it in terms of T. Now T sub Y is T sine 20 degrees. So we substitute that. T sine 20 degrees, of course, times X plus 2000 times M minus, now our T sub X, that is T cosine 20, T cosine 20 degrees times Y, of course, is equal to 0. Now, if you can observe our sine 20 times X, cosine 20 times Y as a common factor, which is T. So we factor out t. And this becomes t bracket sine 20 times x minus cosine 20 degrees times y plus 2000 times m equal to 0. Now what I'm going to do is I will uh, transfer my 2000 to the right hand side of the equation. So this becomes, okay, let me pan it here. Okay. So that my equal sign will be at the same level. So this becomes t bracket sine 20 times x minus cosine 20 times y is equal to negative 2000 times m. Okay, I forgot to put a closing bracket here. Now, for our x, y, and m, take note that our structure is inclined 30 degrees from the horizontal. So therefore, for our x, which is color blue, that is 1.5 plus 0.6, which is 2.1, and its x component of our 2.1, right? Which is 2.1 cosine 30 degrees. So we substitute that here. This becomes, wait, let us divide both sides by what is provided in our bracket. Okay, so this becomes t is equal to, I will do first the denominator because it's quite long. So that's sine 20 degrees times x minus cosine 20 degrees times y. And then our numerator is negative 2000 times m. Now, as I was saying, our x and y is the x and y component of our 30 degrees, and then the hypotenuse would be our distance, which is 0.6 plus 1.5 for our xy, and then the hypotenuse of 1.5 for our m, still using our 30-degree angle. So for our m, all right, for our x, let us start with our x. This is sine 20 degrees times the x. That would be 2.1, and then cosine. All right, x would be, yeah, cosine 30 degrees minus cosine 20 times the y component of our 2.1, that's 2.1 sine 30 degrees. Okay, our numerator is negative 2000 times our m this time will be using 1.5, right? Okay, 1.5, and then cosine 30 degrees. 1.5 cosine 30 degrees. Okay, so if we solve this one, 2.1 cosine 30 times sine 20 should give us 0.622016078 minus 2.1 sine 30 is 1.05 times cosine 20 is minus 0.988. No, sorry. 9 8, 6, 6, 6, 6, 7, 7, 2, 5, 1. Okay, and our numerator would be 1.5 cosine 30. That's 1.299 times negative 2,000, and that is negative 2,598.076211, and that is in Newton. So therefore, our tension is, let us do the denominator first. That's 0.622016,078 minus 0.986677251. That's negative 0.36, and then remain 0.36, 46666171173, and then parenthesis negative 259.8.076 close parenthesis divided by answer should give us positive 7,124.6309 30943 Newton. Now that is our tension if we view, meaning the total tension that our two cables are experiencing if our track ramp has a weight of 2,000 Newton and it is being raised 30 degrees from the horizontal. So since what we are asked is to determine the tension in the cables, so this should give us T, let us have it T prime is equal to T over 2, that is 7124.630943 divided by 2. So the tension in each cable is equal to 3,562.315472 Newton. Okay, that is the tension in each cable. Now, for our, although it is not being asked in the problem, but if we are to determine the reactions a sub x and a sub y, instead of using the value of the tension for each cable, we will be using the 7,124.630943 because this value here, the 7,000, is the total tension that our two cables are experiencing. So that is the amount of tension being applied at B. Okay, so if we do some force summation in either X or Y, now let us say summation of forces X, assuming to the right positive is equal to 0, then this should give us T sub X minus A sub X is equal to 0. So A sub X is equal to T sub X. Now our T sub X would be the value of our T again is the 7,000 tension, calculated tension, and then the angle would be cosine 20 degrees. Now for our summation of forces Y is equal to 0, assuming upward positive. So this should give us A sub Y minus tension Y minus our value, which is 2,000, is equal to 0. So therefore, A sub Y is equal to T sub Y plus 2,000. Okay, so please do that in your spare time.